as we are treating the topic sets. Now for Maths 1101, the first topic we treat is sets. So let's discuss on sets. Now before we proceed, I'll write out what we tend to achieve in these lectures. We have like 6 objectives. So therefore this lesson is split into 2 parts, part 1 and part 2. The first thing of this lesson, we'll define sets and identify the various types of sets. Now, set has a definition and we have the various types of sets. So we define sets as, so the first one is we define sets and identify various types of sets. Now, the next aim is to describe a set by listing or by a rule. Now, we have various description for sets. So the next aim is to describe sets by listing or by rule. So we describe sets by listing or by a rule. Now, the third objective is to identify and define various types of set operations. Now, we have sets, we have types of sets, and we also have set operations. The next aim is to identify and define various types of set operations. Identify and define various types of set operations. Now for this first class, we'll stop here. Let me name it set 1. Now, in our next class, we'll discuss other part of sets such as we'll illustrate sets with Venn diagrams, we'll illustrate set operation using Venn diagrams, and lastly, we'll solve problems on 2 or more set problems using Venn diagrams. Now, I decided to split set into 2 parts because set on its own have 2 parts. We have set operations and we have sets using Venn diagrams. So today we are treating sets and its operation. Now let's define sets and define some terms to help us flexible with the lecture. Now sets. Sets. This is a well-defined collection of objects members or elements. So set is the well-defined collection of objects, members, or elements. Now, the key main word in set is the well-defined collection. Now, without this keyword, your definition for set will be incomplete. Set is a well-defined collection of objects, members, or elements. Now, the set could be abstract or real. Or the objects were collected could be abstract or real. Now, the objects can be abstract or real. Now, let's give examples of abstract objects and real objects. Now, I'll split the topic into have real objects have abstract object. And let's manage best from the tabular form. And I'll give just two examples and explain them very well. Now, for real objects, first year students in a university. First year students in a university. Now for abstract, you can have even numbers between 9 and 21. Even numbers between 9 and 21. Even numbers between 9 and 21. Now let's just take the examples of the view objects and abstract objects that will explain more on this. Now for the view objects, another example is city capitals. City capitals of all countries in Africa. Then for the abstract, we have again English language alphabet. Language alphabet. Now let's take a close look at the examples so we can know the difference. It said sex, the object can be abstract or real. Now for real object examples, we have first year students in the university. Now if something is real, and it's something that is happening, something that can happen, I get it, something that can happen. For example, I can say members of civil departments. Members of civil departments. That's an example of real objects. Members of civil departments. Then for the abstract, as we can also create as many examples like numbers of stone in a rice bag. Numbers of stone in a rice bag. That can be abstract. I get it. And let's progress. Let's move forward. Now we have defined sets. Let's define set notation. Set notation. Set notation. Now set notation. Sets are usually noted by capital letters. Sets. Now, how do you identify a set? You can't name a set with small letters like small a, small b, small c. No. We use capital letters to denote a set, such as capital A, B, C, D, X, Y, Z. Any of them. So sets are usually denoted by capital letters. Sets are usually denoted by capital letters. No capital letters. Example, we have A, B, C, so X, Y, Z. And now, we denote set by capital letters, and now elements of a set are denoted by small letters. Get this correctly. Sets are denoted by capital letters. The elements of a set are denoted by small letters. Then, elements in sets are denoted by small letters. Now let's describe the set. We have defined what set is and how do you set notation. How do you denote a set? Now let's describe a set. Let's describe a set. Description of a set. Description of a set. Let's draw a line here. Now, set is usually described in one of the two ways. Now, we can describe set in one of the two ways which I'm about to mention. Set is usually described. Set is usually described by one of the two ways. Now let's use the two ways you can describe a set. Now you can describe a set by listing or by tabulation. By listing or by tabulation. Now this is a very common one that we know, by listing or by tabulation. Because it's very easy. The set can be described by listing or by tabulation. Let's put one here. By listing or by tabulation. Example. Like I said, sets are denoted by capital letters. The element of the set are denoted by small letters. Example, V equals to this element. Let's say A, B, C. This is a typical example of how we describe sets. V is equal to A, B, C. Now, the second way we describe sets. Now, by stating a rule, otherwise called set builder. By stating a rule, otherwise called set builder. Now, this particular way of describing sets is a more complex way, because we need to apply some mathematical calculations to get the members of the set. So the second one is by stating a rule, otherwise called set builder. Let's write it down. Second one, by stating a rule, otherwise called set builders. Set builders. Set builder form. Now, by setting a rule, otherwise called set builder form. Now, this rule could be formulas. This rule could be formulas. Let's take an example of this rule. Example. Let's say x is equals to 2 less than x less than 5. Now this is where most people get confused. Now this means 2 less than x less than 5. Now for this means x is greater than 2 but less than 5. X is greater than 2 but less than 5. That is, let's write it down. That is x is a set of numbers greater than 2 but less set as a whole and define set and identify various types of set. This is set as a whole. I've known the basic definitions that goes along with set. What is set? Set is a well-defined collection. Well-defined collection of objects, members, or elements. Now, I've noticed that sets, the objects can be abstract or real. As in words go, real and abstract. Real are things that you can see or are happening. The abstract are things that you can imagine. Are you getting me? And the next one is set and notation. Now, sets are usually denoted by capital letters, while members of the set are denoted by small letters. When I put that to the description of set, I can say set can be described using one of the two ways, by listing or by tabulation. Example, V equals to A, B, C. Now, A, B, C are members of the set. It's given out plainly to us. And the next way is by stating a rule, otherwise called set data form. Example, X is equals to 2 less than X, X less than 5. What this means is that X is greater than 2, but less than 5, as easy as that. Now, in most cases, you might be given a formula, like a quadratic formula, you might be given an equation to solve and get the elements of that set. Let's advance to types of sets. Types of sets. Now, let's look at the first type of set, which is very known as subset. First one we treat is subset. That's the number one. Subset. Now, if every element of y is an element of x, then y is a subset of x. If every element of y is an element of x, then y is a subset of x. Then y is a subset of x. Now, how do we write y is a subset of x? We write y subset of x. Now, this sign here that looks like a C denotes subsets, denotes subsets. Where, better understanding, where the symbol there denotes is a subset of, denotes, let's put in parentheses, is a subset of. Then, if this note is a subset of, then what sign written will denote is not a subset of, just a little difference. Then, the symbol now, see the difference here. Cancel it. Now, this symbol denotes is not a subset of. Denotes is not a sub. Let's put in parentheses. It's not a subset of. And this is all about subsets. Let's give examples for better understanding. And I think I'll take out this first board. Let's look at another example of subsets. This main
we'll
class.
wipe out this part. You lock that marker when you finish to this thing. When you finish to use that.
Now let's look at examples of subsets. Examples. We'll just take two examples. Examples. Now example one. Let's say the set V. Set V has the elements A, B, I, O, U. It's a subset. It's a subset of Y. So Y has A, B, C down to X, Y, Z. Now this means Y has all the alphabets A, B, C down to X, Y, Z. That is V is a subset of Y. V is a subset of Y. What this means is that the elements in V, A, E, I, O, U, are contained in the element of the set Y. We have A, B, C, D, E, F, G, H down to Y. So V is a subset of Y. Let's take a second example. The set Nigeria, Ghana, Egypt is a subset of countries of Africa. It's the subset of countries in Africa. Now let's look at universal set. What does it mean to say a set is universal? Let's look at it. Don't forget we're discussing the types of sets. The first one we said is subsets. Now let's look at universal sets. Universal sets. Let's go back there. That won't be confused. Let's name there A. Now B. Universal sets. Universal sets. Now, what does it mean for a set to be universal? The set of elements. The set of elements or members relevant to a particular application, relevant to a particular application. Please note this first part is just to understand the concept of sets. In the next lesson, we'll discuss set operations and Venn diagrams. The set of elements or members relevant to a particular application is called the universal set. It's called the universal set. Now, it is usually denoted by S or U. 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 Let me give an example. Let's avoid writing much. When we talk about students in a university, that is a universal set. Students in a university, that is a universal set. While engineering students, science students, and so on are all members, are all subsets of the universal set. Let's go over it again. Students in a university, everybody in a university, or we have students in a university. Now, inside students in the university, we have departments. We have engineering students, science students, education students. Now, all of them are subsets of the universal set. Now, let's go back. Let's go to the next type of set, which is empty sets. Empty sets.
Ah, you're smart, bro. Pule, the chat, you see that chat? That girl, you think she's ex? You cut and come up. What is the chat? Important chat person, just important. Wait, now, the person comes to me first. That one.
So I would demand the teller.
Now, like I said, next type of set is empty sets. That was A, B, let's give it C. Empty sets. Empty sets. Now, what does it mean for a set to be empty? The set containing no elements is called an empty set. The set containing no elements is called an empty set. The set containing no elements is called an empty set. Now, how do we denote an empty set? It is denoted by phi. Now, this symbol here is called phi. P-H-I. P-H-I. Phi. Now, other names for empty sets can be called no sets or void sets. Other names for an empty set is no set or void set. How do we write it? No set, that is an empty set or void set. Now, example. Let's give an example of a no set, for instance, because it might be asked in a word form. Example of a no set. We have 1a. Please remember that is a squared equals to -4, where a, that is this a, where this a is a real number.